If you have not done so yet, please pause and do these two problems. If you have done these two problems, go ahead and watch the video and make sure you got this right. Let's start with e to the 0.05. Again, I'm going to be thinking of a function here. I'm going to be thinking of f of x equals e to the x. Let's go ahead and find the derivative because I know I'm going to be utilizing that. Derivative of e to the x is e to the x. So we see that f of 0, e to the 0 becomes 1. F prime at 0 is also e to the 0, and that becomes 1 as well. If I want to approximate using differentials, e to the 0.05 is like plugging in 0, adding f prime of 0 times this differential. Differential here of x. We just saw f of 0 is 1, so we can replace f of 0 with the number 1. F prime of 0 is also 1. And the differential dx, well, that is 0.05. We went from 0 to 0.05, so that's a positive 0.05 increase. If I take 1 plus 1 times 0.05, what you get is 1.05. That means f of 0.05 is approximately 1.05. Again, if you'd like to plug this into your calculator, the calculator gave me e to the 0.05 was equal to 1.05, 127, 1096. Now that's rounded to a few decimal places. It actually goes out further. But you can see that this, again, is a pretty good approximation for what the calculator value is. Let's take a look at the next example that we had, cosine of 3. So we're going to start at pi. In this case, my function, f of x, we're going to think of as cosine of x. F of pi is equal to -1. Cosine of pi is -1. F prime, well, derivative of cosine is negative sine of x. And notice what's going to happen here. F prime at pi is simply negative sine of pi, which is -0 or just 0. That's kind of strange in some senses, but expected if we know what the cosine graph looks like. So cosine of 3 would be like inputting f of 3. It'd be like plugging in a pi and then an f prime of pi times the change in x. If we plug in pi into the function, cosine of pi gives -1 plus f prime of pi, that's negative sine of pi, that's 0, times the change in x. Now, in this case, because we have 0, it's not that big of a deal, but notice that 3 versus pi, if you take 3 minus pi, you're going to get a negative 0.1415926, etc., etc., etc. This is telling you that f of 3 is approximately -1. And that's, on your calculator, not very far off. If you take and plug in your calculator, cosine of 3 into your calculator, you'd get -0.9899924,966. Again, that is pretty close to my approximation. Obviously, this time, that slope of the derivative at this point, at pi, was 0. So I had a horizontal tangent line, and that's why we weren't changing. Again, this would be a pretty good approximation when you're really close to pi, but as you get further and further away from pi, it's going to get worse and worse. So in my case, I got, let's do cosine there. And let's take a point on the graph, move it around. As you can see at pi, you're right there. You have a tangent line, which is horizontal. If I graph this horizontal tangent line, y equals -1, you can see what's happening. And so when you're really, really close to pi, this horizontal tangent line does a pretty good job of approximation. As you get further and further away, the horizontal tangent line becomes a worse and worse approximation. At 3, it wasn't like spot on, but it was pretty close, as you can see at 3 here. And obviously, the closer to pi we get, the better approximation it's going to be. So that's how this is working.